Thank you.
Thank you, Alexei. We haven't a question. Okay, the next speaker, Artyom, please.
Hello, everyone. I need to show the...
This I can use my screen with you. Okay. Okay. Hi, everyone. My name is Daniil, and I am a lead software engineer in a T-Bank, one of the largest fintech companies in CIS. Today, we're going to dive into dynamic traffic management. We will use Envoy as a main tool for this purpose, and Docker traffic is an excellent example of how an effective traffic management could be. What does dynamic mean in this context? We will answer the question a bit later. Many of us are used to work with Envoy as a load balancer, for example, in our Kubernetes clusters, say as a part of Istio deployment. Today, we're going to use it from other perspective as a reverse proxy. Let's look at today's agenda. The key topics that we're going to cover today are the dynamic routing with Envoy, the structure of the Docker traffic, and we'll also take a glance at Docker registry authentication protocol. And knowing the details of Docker registry authentication, we will use Envoy external authentication service feature to implement our custom authentication scheme. Last but not least, we will come up with the solutions based on Envoy tools that will help us make the whole system more reliable and stable. As a great example of these topics, we will use a problem that sounds like this. We have two registries, registry 1 and registry 2, and we want to pull certain images from one container registry and other images from the other container registry. And say we want to pull Alpine latest tag from registry 1, and we want to pull Nginx latest from registry 2. Such a problem can occur in a case, for example, when you're considering a migration from one container registry backend to the other. I personally have encountered a similar problem a few times during my career. We will look at the problem from a general perspective. We can suppose that our container registries are some generic clusters, and the proxy server that is going to handle all the logic we talked about previously. As you can see on the slide, the proxy has some configs that we want to use to describe the routing rules for our proxy. And moreover, we want to add an additional features. We want to have to be our traffic authenticated. So we will not have an unauthorized access to the Docker images at our company's registries. Here's when Envoy dynamic routing comes into play. As you can see on the slide, dynamic routing refers to the ability to change request routing behavior in real time based on changing configurations or data without restarting services or proxies. It enables more flexible, intelligent routing of traffic in microservices architectures and cloud environments. Let's look at the key benefits of dynamic routing. The first one is improved flexibility. So we have no need to restart proxies routing can be updated, routing rules can be updated on the fly. The second one is resilient infrastructure. We can automatically reroute traffic in case of service outages or failures. The third one is a traffic control, which enables fine-grained traffic management for load balancing and canary deployments or A/B testing, etc. And the last one is scalability. We can easily scale our microservices architecture using that approach. And the use cases. The first one is A/B testing. I think everyone is familiar with that. Canary releases. I want to focus your attention on this one because this is the point that is exactly the problem that we are trying to solve during this talk. The third one is geolocation-based routing. For example, route users to region-specific services dynamically based on user location. For example, user from one country goes to the specific backend in this specific country. The other users from the other country use the other backend. And the last one is fault tolerance. We want to dynamically reroute traffic during service failures to health instances in real time. So you might ask how to configure the dynamic routing using Envoy proxy. And the answer is dynamic routing can be configured in many various ways, depending on the needs of your system, whether it is a gRPC or REST-based control plane in your cluster, or it's a file-based configuration, or maybe you configure your proxy dynamically using ADS, which stands for a dedicated server for configs. And all this flexibility allows Envoy to handle dynamic routing efficiently in different microservices architectures and cloud-native applications. And in the table, you can see in the middle column the options from config that we can specify to enable any kind of the configuration approach you want. On the next slide, you can see the beginning of the stand that we are going to deploy during our talk. I wanted to make this whole presentation as much useful as possible, because if you take the configs that I provide and try to create your own stand on your local machine, I think eventually you'll get the working example of the situation of the problem that we're trying to solve here. So if you're having some troubles, maybe repeating some steps, you can contact me and I'll help you with that. So we'll use Docker Compose file as a tool to quickly install Envoy, and we will configure it to pass config files as a volumes. We have 3 config files. Envoy.yaml is the first one and the main one. LDS.yaml is the file with the clusters and description of clusters. And the third one is the routes, the file that contains routes configs. The only one variable that is required is the envoy conf, which specifies where our config is located. On the right part of the slide, you can see the contents of the envoy.yaml file. And the first section just describes the Envoy cluster itself, node itself, sorry, the name of the cluster, the ID of the cluster, etc. And 2 other sections that are required. One is dynamic resources. Here's where we put our LDS.yaml file that, as I've mentioned earlier, describes our clusters. And static resources describes what our clusters are, like which endpoints do we have, how to connect to them, which ports do we use, and etc. On this slide, you can see the contents of the lds.yaml file, and the main part of it is the HTTP connection manager section config. Sorry, and in this section we attach our routes file, and we will be using configuration with using a file. And a key benefit of using a file is that you can swap one file with another, and your configs will be updated just in place. Okay, we have finished with Envoy configs. So let's take a look at our second part of our speech is Docker traffic structure. So let's start with the basics. The main part of a Docker image is its manifest. In manifest.json, you can find a lot of useful information such as platform of an image, digest, and sizes of Docker image layers, some additional meta information. The first thing that Docker is going to perform when you type Docker pull in your terminal is fetching a manifest. And manifest is stored as a part of an image in a container registry together with layers and configuration blobs. If you want to inspect a manifest of a certain image, you can type docker inspect command as shown on the slide. So let's examine the workflow of a Docker pull command. First thing that Docker client does is starting the authentication flow by calling get/v2 endpoint. Don't worry, we will look at the details of the Docker registry authentication process a bit later. Now just focus on the overall structure. And if the authentication was successful, Docker begins a download of an image starting with a manifest request. And as we've discussed earlier, manifest contains all of the hash sums of an image layers. So Docker client can easily download all of the layers, referencing them by digests. And after we have all of our layers, our image is fully downloaded. Moving on to Docker push operation. It's a bit tricky, I would say, but in general, idea stays the same. We have our authentication in the beginning, and then comes the difference. An upload starts by calling post uploads handler of the registry API. We must say that Docker optimizes the upload process by checking the existence of each layer by calling head/v2 and so on methods that can answer whether a specific blob exists in the registry or not. So if blob already exists, we will skip the upload of this exact blob and we will go to the next one. So then if there is no blob with such digest, Docker can upload blob by using an ID of the upload. And in the end, it will upload image manifest. And one important thing to mention here is that Docker performs multiple uploads simultaneously to speed up the upload process. So we know what Docker registry routes are. So we can now use that knowledge to route different images to different registries. On the slide, you can see an example configuration, which can be used to route Docker requests to different registries. we can see that Alpine image will go to registry 1 and Nginx will go to the registry 2. Just as we stated in the beginning of our talk. By using prefix option, all of the roads, manifests, layers, and config will be included. So we don't have to describe them separately. Note that I left wildcard in the domain option, but if you want to use more than one domain, it will be no problem. So just change it. You might have more complex needs to traffic related to traffic management. For example, you might want to route requests with a specific header or route requests by using regular expression instead of a prefix, and etc. All of these and even more can be easily done with the Envoy routing. As in the second example on the slide, Envoy will replace all requests to latest tags with the request to specific version of an image. In our case, it's release version 1. One of the pro tips that I want to share with you is configuration templating. Many of you probably have used Ansible and are familiar with J2 templating. You can put, for instance, image names in a separate file and generate roads dynamically as shown on a slide. You can extend this idea and create a CI/CD pipeline to automate the process of deployment. So there will be no human interaction, human part in the process, and everything will be automated. Okay, one thing that we haven't mentioned earlier is how exactly do we update our config file. The operation itself is pretty easy. We just use our Linux move command. For example, we have a rds new.yaml file, which contains the most recent configs that we've updated. And we just replacing the old file with the new one. And as some of you may know, this will trigger an iNotify event inside a Linux kernel, and Envoy is listening to that event, and it will update its road configuration when you perform move operation. But in my experience, when I was trying to use that feature in Macs or Windows, because these platforms use virtualization technologies, such things as Linux kernel features may not work correctly. So be aware of that. And if you want to repeat the process that I'm describing here, you better use Linux systems. A bit earlier, I've talked about that we need to authenticate the traffic, and how do we want to achieve that? Of course, you can implement authentication logic in your registry backend code, but these backends can be very different one from each other, and you will have to implement this logic in every backend. But you may also have an external authentication provider, maybe a provider that is used in your company, and you want to integrate it with your container registry so it will authenticate your docket traffic. To enable this, you have to add an HTTP filter and specify a service that will authenticate requests. An example configuration of an HTTP filter is shown on the slide. Let's take a look at this example configuration. This should be put under the HTTP filter section that we've seen at one of the previous slides. Note that you have to specify patterns for headers that you want to pass or receive from your auth service. It is a very security sensitive place, and make sure to manage request headers very accurate. Among other things, we specify which of Envoy clusters is used as an external authentication service. In our case, it's auth service. It's called auth service. And having the knowledge of Envoy external auth feature, let's take a closer look at Docker Registry Authentication Protocol that we've mentioned earlier. Docker uses two key endpoints, the V2 endpoint. The purpose of it serves as an entry point for all Docker registry APIs. It is used by clients to verify that the registry supports API of version 2 and is functional. A Docker client or tool, for example, Docker push or Docker pull-up relations, will first send a GET request to /v2 to confirm the registry is using the correct version of API and ready to accept further requests. The endpoint can return OK or unauthorized responses. The second one is the /v2/token endpoint, and this endpoint is used to obtain an authentication token that allows the Docker client to perform subsequent operations such as pull or push against a registry. It's primarily used when a registry requires token-based authentication. The authentication flow is you have to send a request to v2/token, and the registry will respond with the token that has the scopes that we need, or it will send you an unauthorized response that will indicate that you have to pass additional information, maybe a password or username, and etc. So let's examine the whole flow. First, the client initiates a push or pull request to the registry. Then, if authentication is needed, the registry responds with an unauthorized status, providing details on how to authenticate. Third, the client then requests a token from the authorization service. The authorization service issues a token that represents the client's access rights following the format outlined in the authentication token implementation, and the client resends the original request, now including token in the authorization header. The registry then validates the bearer token and its claims, allowing the push or pull process to proceed normally. Moving on to the Envoy routes configuration, we can now add two endpoints. First one is the /v2 endpoint we've talked about earlier, and also a v2/token endpoint. Note that we've added an additional section with typed per filter config, which disables authentication for these two routes because we only need to authenticate requests, for example, for blobs, for manifests, for configs, but these endpoints are authentication itself. So just to break this, do not get into the loop in our service. So now we know how Docker authenticates requests. We know the structure of Docker traffic. We know how to configure Envoy to route requests to different container registry. We know how to authenticate these requests. We want to make our system more reliable, and Envoy provides a lot of features to achieve that behavior. For instance, it's automatic retries. For example, if request to the registry fails, we can retry it, but use a different instance of our registry. And to configure it, you have to add a retry policy section in your roads configuration. As an example, we've talked about road for V2 Alpine, to road Alpine image requests to container registry number 1. We just add the retry policy section below, and we specify that we want to retry gateway errors, which means that we will retry 500 and so on errors. For example, 503. And then we specify the number of retries we want to perform. In our case, let's say it will be 2. And we specify the strategy that we select the next backend from our pool. For example, if we have 3 nodes for our registry, we can add 2 retries. So if the first one fails, then we'll take one of the remaining hosts to perform requests again. And if everything is fine, the request will be successfully retried. So we've just made our system more reliable by adding a few lines to our configuration. The next thing that can make our system more stable is outlier detection. As in previous example, let's say that we have 3 nodes and one of them for some reason fails to process the request, and Envoy can detect such hosts in cluster and temporarily disable them and remove them from rotation. To achieve that, you have to configure outlier detection in your cluster configuration. As you can see on the next slide, this is the envoy.yaml file static resources section. We previously had our cluster for registry 1, and we just add a section called outlier detection. And we specify the time for which our failed host will be removed from rotation. For example, here it's 5 seconds. Then the interval that we want to make such checks, then maximum ejection time, and etc. Below we can see the different types of errors or like situations when we can use outlier detection. In our case, we just use it for gateway failures. We can also like enable it when we have too many 500s, or maybe when success rate to specific node like below certain percent or etc. And the last but not least thing is health checking. As some of you may know, health checking can be active or passive, and it's how it works. It regularly assesses service health to ensure traffic is routed only to healthy instances. To set up it, you have to define health check parameters within the cluster configuration for proactive monitoring. And that is it for today. Thank you for your attention. I'll be glad to answer your questions.
Thank you very much.